Welcome to KJR SummaryCast. SummaryCast provides audio summaries of KJR articles created using an in-house AI tool with editorial or author review. For full details, please refer to the original article. Welcome to SummaryCast.
Today, we're looking at a paper from the April 2026 issue of the Korean Journal of Radiology. It's titled Ultrasound Imaging Features Associated with Neoplastic Gallbladder Polyps, a Systematic Review and Meta-Analysis.
Gallbladder polyps. This is a topic that comes up constantly. They're found all the time on abdominal ultrasound, and the vast majority are completely benign.
Right, but a small fraction, about 4 to 10%, are neoplastic with malignant potential, and that creates a real diagnostic dilemma.
The classic challenge of finding the needle in the haystack. How do you distinguish the harmless polyps from the ones that could become cancerous using just an ultrasound?
Exactly. The size threshold of 10 millimeters is widely used as a key predictor. But beyond that, the diagnostic utility of other imaging features has been, well, debated.
There's a lot of variability in the literature and in practice. Different guidelines sometimes emphasize different things.
Precisely. And that's the gap this meta-analysis aims to fill. It was conducted as part of the process for developing the 2025 guidelines from the Korean Society of Abdominal Radiology, or KSAR.
So the goal was to generate robust, quantitative evidence to inform those recommendations, to move from expert consensus to something more data-driven.
You nailed it. They wanted to identify, with statistical rigor, which specific ultrasound features are significantly associated with neoplastic polyps.
Okay, so this is a systematic review and meta-analysis. How big was it? What was the scope?
It was quite comprehensive. They searched major databases, Medline, Embase, Cochrane, and KoreaMed, and ended up including 30 studies published up to August of 2025.
And the patient numbers?
The final analysis included data from 8,953 patients.
And how many of those had confirmed neoplastic polyps?
That would be 1,216, which is about 13.6% of the total cohort.
That's a solid sample size. What was the core methodology here?
They evaluated 9 distinct ultrasound imaging features. For each feature, they used bivariate random effects models to calculate the pooled diagnostic odds ratio, or DOR, along with sensitivity and specificity.
Let's define that. The DOR is a single metric that summarizes diagnostic performance, right? A higher DOR means the feature is better at discriminating between the two conditions.
Exactly. It combines sensitivity and specificity into one number. A DOR of 1 means the test is useless, and the higher it gets, the more informative the feature is.
Got it. So they ran the numbers on 9 features. What was the top-line result?
The main finding is that 8 of the 9 evaluated features were in fact significantly associated with neoplastic polyps. Only 1 feature didn't make the statistical cut.
8 out of 9. That's a lot. Let's break them down. Where should we start?
Let's start with the most established one, size. Specifically, a size of 10 millimeters or greater.
The one everyone knows. What did the meta-analysis show for it?
It confirmed its importance with a pooled DOR of 6.23, but what's really telling is how its performance breaks down.
Meaning sensitivity versus specificity.
Right. The size criterion had the highest pooled sensitivity of all 8 features, coming in at 0.79.
79% sensitivity. In practice, that means using a 10 millimeter cutoff is the best way to catch the neoplastic polyps. It's good at not missing them.
It is. It casts a very wide net. However, the specificity was modest at just 0.62.
So while it's sensitive, relying on size alone means you'll end up recommending surgery for a substantial number of benign polyps.
That's the trade-off. It prioritizes not missing a potential malignancy at the cost of including many false positives. It's a foundational feature, but it's not the whole story.
Okay, so size is confirmed as an important but imperfect starting point. What about morphology?
Sessile morphology, meaning a broad, flat base, was also significantly associated. It had a DOR of 3.54.
Again, another feature that's pretty well accepted in guidelines. So this provides the quantitative backing for that recommendation.
Precisely. It confirms the relevance of assessing the polyp's shape as a key part of the risk stratification.
All right, those are the familiar ones. What did the analysis find that was more surprising or perhaps stronger than we might have assumed?
This is where the results get really interesting. The two features with the highest diagnostic odds ratios were gallbladder wall thickening, or GBWT, and vascularity.
The highest. What were the numbers?
For vascularity, the DOR was a remarkable 9.72. For GBWT, it was just behind at 9.38.
Wait, a DOR approaching 10? That's a very strong signal, much stronger than the 6.23 for size.
It's a powerful finding. These two features were the strongest predictors in the entire analysis. It suggests that if you see either of them, the likelihood of an underlying neoplastic polyp increases substantially.
Let's talk about the practical implications of that, especially for vascularity. Its role in guidelines has been inconsistent.
It has. The Society of Radiologists in Ultrasound, or SRU guidelines, concluded that vascularity shouldn't influence risk stratification due to limited evidence. Others, like the WFUMB, suggested it could be useful.
So this meta-analysis provides the high-level evidence that was previously lacking. What about the specificity of these two features?
They were both highly specific. GBWT had a pooled specificity of 0.91, and vascularity was at 0.88.
So they are excellent rule-in signs. If you see a focal wall thickening adjacent to a polyp, or you detect flow within it on Doppler, you can be quite confident it's a high-risk lesion.
That's the takeaway. The sensitivity for both was more modest, around 0.42 for GBWT and 0.56 for vascularity, so their absence doesn't rule out neoplasia, but their presence is a major red flag.
The study mentions that the definition of GBWT was inconsistent across the source papers, which is a potential issue.
It is. And the meta-regression analysis dug into this. It found that the study's country of origin was a significant source of heterogeneity.
How so?
Studies from Western countries, which tended to use a more precise definition like focal GBWT, showed a substantially higher specificity, 97.6%, than the East Asian studies, which often used the broader term GBWT.
That's a critical point. It underscores the need for standardized, precise terminology. Adjacent focal gallbladder wall thickening is not the same as generalized thickening from, say, adenomyomatosis.
You nailed it. The finding supports using the more specific definition to improve diagnostic accuracy.
Okay, so we have four major predictors: size, sessile shape, and then the two heavy hitters, GBWT and vascularity. What were the other significant features?
The next cluster of findings revolves around the internal echotexture of the polyp.
Such as?
First, hypoechogenicity. This feature had a moderate DOR of 3.55, but what was truly notable was its specificity.
Let me guess, it was high.
The highest of any feature in the entire analysis, 0.93.
93% specificity, so it's an infrequent finding. The sensitivity was only 19%, but if you see a hypoechoic polyp, it's very likely to be neoplastic.
Precisely. It's a powerful, though rare, indicator. The other echotexture feature was the absence of hyperechoic spots.
This one is interesting. It's a negative finding. You're looking for the lack of a benign feature.
Exactly. Hyperechoic spots are characteristic of benign cholesterol polyps. Their absence, therefore, raises the suspicion of neoplasia.
And the numbers back that up?
They do. The absence of these spots had a DOR of 4.23 and a sensitivity of 0.75. So not seeing those bright spots is a reasonably sensitive way to flag a polyp for closer scrutiny.
When you combine these two, it paints a picture. A suspicious polyp is more likely to be hypoechoic and lack the bright, echogenic foci of a cholesterol polyp.
That's the idea. It moves beyond just size and shape to the texture of the lesion itself.
Okay, that covers 6 of the 8 significant features. What were the last 2?
The last 2 were single polyp and the presence of coexisting gallstones.
And what did the data say about them? I'd imagine they aren't as strong.
Your intuition is spot on. While both were statistically significant, they had the lowest DORs of the entire group. Single polyp had a DOR of 2.21.
So being solitary does increase the risk, but the signal is weaker. What about gallstones?
Coexisting gallstones had the lowest DOR of all significant features, at just 1.86. The pooled sensitivity was also very poor, at only 0.24.
So while a statistical link exists, perhaps due to shared risk factors for stones and neoplasia, the presence of gallstones is a weak, independent predictor of a polyp being a neoplastic.
That's what the data suggests. The authors conclude that these two features should not be weighed as heavily as other, more high-risk characteristics like vascularity or GBWT.
This aligns with some guidelines that don't prioritize these as primary drivers for surgical intervention. It's part of the picture, but it's not the headline.
Well put. And just to round it out, the one feature that was found to be not significant was heterogeneous echogenicity. Its confidence interval crossed 1, so no reliable association was found.
Okay, let's zoom out and interpret all of this. What's the bottom line clinical message here?
At a high level, the study provides a strong quantitative foundation for the features many radiologists already look for. It confirms the importance of size, sessile shape, and adjacent wall thickening, the cornerstones of the KSR guidelines.
But it does more than just confirm. It seems to create a hierarchy of evidence. It suggests not all risk factors are created equal.
Exactly. That's the key insight. Vascularity and GBWT emerge as particularly powerful predictors, with odds ratios that are substantially higher than even the 10 mm size rule.
Which could refine risk stratification. Instead of a simple checklist of present or absent features, this could pave the way for a more nuanced, weighted risk model.
That's the potential. The presence of intralesional vascularity or adjacent wall thickening might justify more aggressive management or closer follow-up, even for polyps that are slightly smaller than the traditional 10 mm cutoff.
It quantifies the risk in a way that allows for more informed decision-making. That's a valuable contribution.
It is. It translates qualitative observations into quantitative evidence.
Now, let's talk about the weaknesses. No study is perfect, and meta-analyses are particularly susceptible to certain biases. What are the caveats?
The authors are commendably transparent about the limitations. First, they detected evidence of publication bias for 4 of the features.
Which 4?
The coexisting gallstones, GBWT, hypoechogenicity, and the absence of hyperechoic spots.
So for those features, it's possible that studies with significant findings were more likely to be published, which could potentially inflate the summary estimates we're discussing.
That's the risk. It's a common issue in meta-analyses, and it's an important grain of salt to take with the results.
What else? We already touched on the inconsistent definitions for GBWT.
Right. That lack of standardized terminology is a major source of heterogeneity and noise in the data. The same issue likely applies to the assessment of echogenicity, which can be subjective and vary between studies.
And the overall quality of the included studies, how did they fare?
The quality assessment using the Quadis tool showed that a substantial proportion of the included studies had methodological concerns, particularly around the risk of bias in how patients were selected or how the reference standard was applied.
So the foundation of the meta-analysis, the primary studies themselves, has some cracks.
It does. These inconsistencies and potential biases mean the results, while powerful, need to be validated with future studies that use standardized criteria and rigorous prospective designs.
Fair enough. So let's land this. What are the final actionable takeaways from this paper?
The paper successfully identifies and, more importantly, quantifies a set of 8 ultrasound features that are significantly tied to neoplastic gallbladder polyps. It provides the high-level evidence needed to support and refine clinical guidelines.
And it highlights a clear hierarchy. Vascularity and adjacent gallbladder wall thickening are shown to be particularly potent red flags, with high diagnostic odds ratios and excellent specificity.
That's right. Conversely, it suggests that features like a single polyp or coexisting gallstones, while statistically significant, are much weaker signals and should likely carry less weight in the final assessment.
So, for the practicing radiologist, this work reinforces the importance of a comprehensive evaluation beyond just measuring size. It puts numbers to the features that should raise suspicion and trigger a recommendation for closer follow-up or surgical consultation.
Precisely. It's a foundational analysis that helps sharpen diagnostic thinking around a very common and clinically important problem.
A well-engineered study that brings a great deal of clarity to a complex topic.
And that concludes this episode of SummaryCast.